Here's a question most people in the tech world rarely ask. When your video call connects seamlessly across continents, when billions of messages zip through the internet in milliseconds, or when a global stock trade happens faster than you can blink, who makes all that possible? You might say software developers. Maybe data scientists. But the truth is, it's the IP MPLS engineers, the quiet architects behind the world's digital nervous system. They are the unseen problem solvers who make sure your data doesn't just travel fast, it travels right. They're the people who keep the internet together, even when the world feels like it's falling apart. Welcome to the Christian Omeni Tech Channel, your trusted hub for cutting-edge tech insights. If you're passionate about technology and want to stay ahead of the curve, you're in the right place. Subscribe now and join our growing community. Let's start with the basics. Every app, every call, every connection runs on packets of data. But packets don't just move randomly. They need roads and intelligent traffic systems, and that's exactly what IP MPLS networks are. Imagine the internet as a massive city. IP, or Internet Protocol, is like the addressing system that tells every piece of data where to go. MPLS, or multi-protocol label switching, is the superhighway network that ensures data takes the fastest, most reliable path. Together, they create the communication fabric that powers our modern world. The engineers who build and maintain this are like the urban planners of the digital age. They design routes, balance traffic, and prevent digital blackouts before they ever happen. Most people never see them, but without them, everything from your Netflix stream to an emergency call could crumble in seconds. So, what does a day in the life of an IP MPLS engineer look like? Picture this: it's 2 a.m. Somewhere in a dimly lit network operations center, an engineer stares at a wall of screens. An alert flashes red: a major link between Lagos and London has dropped. Traffic reroutes instantly, but latency spikes. The engineer doesn't panic. They trace the fault and reroute traffic across an alternative MPLS path in seconds. Users never even notice. The network heals itself. That's what makes them heroes. They live in a world of routing protocols, BGP sessions, and quality of service policies. Each decision they make affects millions of packets per second and, by extension, millions of lives. Their job isn't glamorous, it's demanding, invisible, and deeply technical. But it's what keeps our digital world alive. Let me share a real-world story. A few years ago, a major submarine cable cut off the coast of West Africa caused several internet providers to lose their international links. Internet speeds plummeted, and panic spread. But one network stood firm. Why? Because their MPLS core had redundant paths configured through alternate terrestrial routes. Traffic automatically rerouted through inland fiber networks, and customers barely noticed the disruption. That's not magic, that's engineering. It's the power of a resilient IP MPLS backbone. When you hear phrases like 5 nines of availability, that's the world these engineers live in. It's a realm where downtime isn't just an inconvenience, it's a headline. Here's something most people don't realize: while the spotlight shines on AI, cloud computing, and cybersecurity, none of those technologies can function without a reliable IP MPLS infrastructure. Think about it. The cloud runs on top of IP MPLS. 5 backhaul, IP MPLS. Voice over LTE, video streaming, fintech all depend on IP MPLS for traffic prioritization and low latency. It's the invisible skeleton of every digital innovation we celebrate. When a satellite beams data from space, it still lands on Earth through terrestrial MPLS nodes. When financial traders move millions in milliseconds, it's MPLS that guarantees those packets get priority. Without this foundation, the digital world would collapse under its own weight. Most people see a router as just a blinking box. But an IP MPLS engineer sees a living organism. They understand the subtle dance of routing protocols, the way traffic finds new paths when links fail, and the art of traffic engineering. It's like playing chess on a board that changes every second. They work in the shadows, often under intense pressure, but their work defines reliability in a world that demands always-on connectivity. When a data center goes down during a critical event, it's not just about fixing cables, it's about protecting trust and stability. These engineers don't wear capes. They wear headsets and speak the language of packets and prefixes. And every time your video call stays clear, somewhere, an IP MPLS engineer quietly made that possible. Let's look at how telecoms were transformed. Traditional operators used to run separate networks for voice, data, and video, which was costly and inefficient. Then came IP MPLS, unifying everything under a converged core. Voice, data, TV, and corporate VPNs all transported over the same intelligent backbone. This allows telcos to offer enterprise services, 5 backhaul, and internet transit from one unified platform. In countries where connectivity is expanding fast, MPLS networks have been the unsung heroes behind digital transformation. When banks migrated to centralized data centers or remote towns got for coverage, it was MPLS that carried the load. And the field is evolving. The next generation of networks is moving towards segment routing, a simpler, more scalable architecture that makes traffic engineering even smarter. Imagine a network that can self-optimize in real time. Add in software-defined networking and AI, and you get networks that don't just move data, they think about it. This is the future IP MPLS engineers are building. As 5G, IoT, and edge computing grow, their role becomes even more critical. Autonomous vehicles, for instance, need real-time communication without drops. All these future technologies depend on the IP MPLS architecture to function seamlessly. So why don't these engineers get the spotlight? Because when everything works, nobody notices. You only notice the network when it fails. Their success is measured by silence, by the absence of outages and delays. But every uninterrupted video stream, every flawless online transaction, all those invisible victories belong to these engineers. They are the reason you can connect with a loved one across the ocean or close a business deal from your living room. Over the years, I've spoken with many IP MPLS engineers, and one thing stands out: their mindset. They think in systems and plan for failure before it happens. They'll tell you, it's not just about configuring routers, it's about building trust in connectivity. It is easy to forget that behind the acronyms are real people who miss family dinners because a link failed at midnight. People who troubleshoot under pressure because millions depend on them. Their world is technical, yes, but also deeply human, because connectivity is about people. When a child in a rural village streams an online class or a doctor performs telemedicine surgery, an IP MPLS engineer's work makes that possible. So, the next time you hear about innovation, remember the stable, secure network holding it all together. If you're an aspiring engineer, take pride in learning these foundational skills. The more the world moves to the cloud, the more valuable they become. Imagine the world in 10 years. Autonomous drones, smart factories, and entire cities managed by sensors. All of this will require massive, ultra-reliable connectivity, exactly what IP MPLS networks are evolving to provide. We're moving toward a world where networks are self-driving and self-healing, but we'll still need the wisdom and foresight of human engineers to guide them. So, are IP MPLS engineers the unsung heroes of telecom innovation? Absolutely. They build the foundation that every other innovation stands on, keeping the world connected and ready for the future. If this story inspired you, please like, share, and subscribe to the Christian Omeni Tech channel. We're building a community of engineers, dreamers, and innovators. New videos drop regularly. From deep dives into telecom systems to discussions on the future of connectivity, join us. Because the future is being engineered, one packet at a time. Thank you for watching.